This video was sponsored by AMD.
Hey, this is James from RedMonk. I'm here with Anush Elangovan, VP of AI for AMD. We're going to talk about the future of GPU programming in the AI era. So obviously, everybody is excited about GPUs. We've had a pretty good run with the market dominant, and now things seem to be opening up. And there are some interesting new opportunities and technologies that are going to probably begin to change the game in terms of what we expect around programming GPUs. So, Anush, I think we're going to start with, the favorite name when we did a little bit of prep, and you mentioned ThunderKittens. So, I mean, if we didn't dive into ThunderKittens, what kind of a tech podcast would this be? Tell me a little bit about ThunderKittens.
Yeah, so ThunderKittens is work that came out of like research from Stanford, and we at AMD had actually worked with them early on. We had actually shipped them some MI210s to when they were early in the early stages of prototyping, and they actually have a port working on MI350s right now. ThunderKittens is a fundamental shift in how you express programming of the GPU interfaces. So let's just take a step back. GPUs in general, CPUs versus GPUs, right? Like the general trend was you had SPMD, which is like, process, each process can do its own thing kind of thing on CPUs. But then you had SIMD, which is, a thread-based architecture for GPUs, right? So you have a whole slew of threads that work on, certain data leading to massive parallelism, but limited, instruction sequencing and things like that, right? So that's the SIMD architecture. Then over time, we kind of discovered that, hey, SIMD is good, but we need these like gems, and the MatMul units are like the key part of AI workloads. So increasingly, we started to see these quote unquote tensor cores or MatMul units that showed up. And the MatMul units are used for matrix multiplies. But for the early stages of it, we were trying to use the SIMD programming model to program the tensor cores, and that didn't really work too well. And you had to do a little bit of like mental gymnastics to, get the layouts right, etc. But what you get with tile-based programming is a native representation that is good for MatMul units, right? So you can actually represent them in tiles, and you could do m by n, k, etc., right? So it's easy to program in tiles rather than in threads. And so that's the fundamental shift that's happening right now as MatMuls start to take on majority of the AI workloads. If you profile a model, 70-80% of it is like between gems and attention. You have all of the big heavy lifters in that part, right? So you wanted something that could be easy to program in that space. And so ThunderKittens was one of those efforts that I'd had the privilege to chat with Chris Ray from the Stanford AI Lab and Ben Spector, who worked on that, to kind of like express a very clean way to program to these tensor cores and matrix cores. But ThunderKittens is just one attempt at it, which is a platform agnostic attempt. But then you have the similar attempt from Qt DSL, which does it on the NVIDIA side, and then there's also the Gluon, which is like a Triton backend that allows for tile-based exposure, which could intercept Qt DSL. But then we also at AMD, we have some experimental models that we're working on, the experimental programming languages that we're playing with called Wave DSL, which provides the same kind of overlap between thread and tile-based programming. And I think there's a bit of these combinations of programming languages that are evolving. We still don't have a clear, like, hey, this is how the future is going to be. But in general, the abstraction is getting higher to make it easier to program. It's getting more Pythonic. and it's getting tile based. If you were to summarize the trends of this.
Okay, so in terms of this Pythonic question and developer productivity cross-platform, do you have any views on and it's been interesting to see this. There's a lot of excitement with Modular and Mojo. Obviously, Chris Lattner has a great sort of track record with Swift, and so I think there's a lot of excitement about what he's doing. The notion of a cross-platform Python-like syntax, where that's going, is that going to be part? Is that something that you've been looking at? Is that something that?
Yeah, very much so. We work with Chris closely. In fact, I met him last week in Austin when he was there at the ROCm 7 launch event to demonstrate how they had been able to port Modular and Mojo to AMD's platforms. The way we think of it is we want this innovation to thrive, right? Like we want ThunderKittens to be successful. We want Mojo to be successful. We want Triton to be successful. And we want, Gluon, Triton Gluon, or Helion that's also coming from PyTorch team. So going back to the original question of what is ROCm and why is it important? It's because it's an AI stack for everyone and it's open source. So all of these components can sit on it, and we will, wholeheartedly embrace each one to have the best kind of win or, whatever gains adoption. We want to be able to enable that if that's what customers want to use. So our general philosophy holds enabling everyone, but Mojo in specific, we've had a big hackathon with them a few weeks ago, or a couple months ago maybe, and then Chris presented at the ROCm 7 launch. And I think there were some other joint announcements that we were making with them. So we want to be everywhere, that is on the forefront of Pythonic DSL evolution. And it's a trade-off. Usually it's a trade-off between functionality, flexibility, and performance. But the closer you can get that and the faster you can get that deployed, makes it easier for actual consumption.
Okay. And what about other sort of traditional programming languages? Pretty clearly, Python has been, I guess, the language of AI. But if we think about certainly the language that people are building applications that touch models, that's TypeScript everywhere. One assumes that I remember when big data, everyone was like, oh yeah, big data is going to be Java, and then Java comes along. Is it all going to be Python? Or are there some opportunities in terms of, are you seeing any interesting innovation in around GPUs and the more traditional programming languages rather than some of the thing that's just been built, as you said, specifically around tiles or basically explicitly built and designed purely with AI in mind? I mean, does general purpose begin to play a role here? And where does that touch GPUs?
Yeah. So it's a very good question, right? So you can skin the problem two ways. One is you start from what is most deployed and try to make that good, right? That's incrementalism, which is perfect for certain classes, right? Mm-hmm. Then there is the hey, I want to start with a clean slate and do it what is the perfect way to do it, right? So Triton and the like are from, hey, we got Python, don't try to redo all of the constructs of it, but try to get GPU programming. You use some decorators here, there. You still have the GIL you have to work through. Then the Python community tries to work through that issue. So it's we'll make good, solid progress. It changes. But then there's the other end of the spectrum, which is, what Mojo takes, right? It's okay, here's a clean slate. If I were to, build this from the grounds up, completely clean and without any shackles and build first principles up, how would that look, right? There is, there's benefits to both, right? Which is, this is incremental, so the worst case is like, oh, you tried something, didn't work, you have at least the last thing to fall back. In the clean slate approach, you aim for something and you start digging a tunnel, and you may end up at exactly the point you want to be, but you may also miss it by a mile, and you'll be like, okay, you got a great programming language and a great paradigm, but no adoption, right? So, but we can't really foretell what that is going to be, but you need both in life, right? You need one is the PhD student trying to explore what's the art of possible. The other is like, okay, I'm just trying to like move the ball forward, but the one sets the North Star for where you can end up. The other is like, okay, I have to be incremental to get to that North Star. But sometimes when it works out, you make this giant leap, right? And that's when, that bet that you've put on like a clean slate approach just fundamentally rewrites everything. And you're like, okay, great. So now all of that incremental, thing can be like as baggage. And then you just say, okay, this is the new future. But getting to that new future, it takes a little bit of like making sure you're doing the right thing, but also you want to make sure that you're lucky, which is so you can do everything right, and it may just not be the what the market adopts, right?
100%. I mean, establishing like
in the history of computing. Sorry, you were going to say.
Well, all technologies, in fact.
Yeah.
I mean, the best technology doesn't always win. And you have to get an awful lot of things right, especially in programming languages and programming terms. I mean, you can have something that's beautifully designed, but without the right frameworks around it, without the right community around it, it's not going to see adoption. So yeah, no, that's exactly right. So, I mean, in terms of, there is this interesting pattern at the moment where, so I mentioned Python again. You look at I saw a very interesting conversation actually just this morning on social, and it was somebody saying, oh yeah, people say, Python isn't good for production. Well, if it wasn't good for production, try telling that to OpenAI, because pretty clearly it is in production there. And then in the comments, somebody pops up and they're like, I work at OpenAI, and let me tell you, running in production is not the high bar. That's just that's the floor, not the ceiling. Mm-hmm. And in fact, I've just joined the company to come in and rewrite some subsystems in C++. So this pattern of Python rewrites in C++ that we're seeing in the Valley, I mean, I guess that's some of the context for some of these efforts that we're seeing here, going back to modular again.
Yeah. I think this Python C++ thing, I will just tell you, I've had this conversation, so many times. It's almost like formulaic right now in terms of, but my general take on it is prototype fast with Python. And if you need the last 2% for your MLPerf submission, rewrite it in C++. That's fine, right? But in general, if you get 98% of the performance in the first 2 weeks of doing it, that's okay, even when you're at scale, right? Like even when you deploy like 5,000 GPUs or whatever, or 10,000 GPUs, 20,000 GPUs, mm-hmm. If you get to the 95th percentile or 97th percentile, obviously OpenAI and others may have different, they may want the last 2% because that would mean $200 million or $500 million of like exposure, right? But in general, for the common deployments, if you're in the 95th percentile plus, that's okay to leave on the table for the speed of execution. And that's why when I say like, speed is the moat, I always refer to not just speed of like how fast your hardware is running or your software is running, how fast your entity can adapt to change and deploy change, right? That is speed too. And that speed favors PyTorch and Python-based approaches. But then when you get to the point where you are at scale at like 400,000 GPUs are humming away, and if you make one change, right? This is like in the early days of Google where they just tweaked the google.com page that loaded, and I think it saved like so many hundred CPUs in the back end because how you compress the first page to load, or, things like that, right? Like, yes, at that scale, it will be important, and they will be on the frontier of like, okay, should we do a C++ rewrite, or should we do Python with no GIL support and get the GIL-less Python to work? Because theoretically, GIL-less Python should work, but now GIL-less Python is also something that you need to like get your brain to grok, right? Like it's not just it's not just like, oh, pthread creates something and like magically parallelism happens without the GIL. You got to think asynchronous in Python, which is like, oh, I can't do the normal Python-y stuff. So is this Python? Sure, it's like it's got the syntax, but now you're thinking asynchronous events and stuff, right? And then you're like, okay, what happened to the Python that I knew? Right? But then it becomes a C++ thread wrapper, and at that point you're like, okay, what's the difference between writing it in Python and that? Because your application code doesn't port directly to the no-GIL Python anyway, so you got to actually architect it well, and at that point, it's as good as C++.
Okay, interesting. So you're still pretty bullish on Python. You don't think that?
I think I do not pick sides, and I will put my foot to the pedal or to gas every combination of like the ecosystem, right? Which is, if it's Python, great. If it is Triton and Gluon, great. If it's Helion, great. If it's ThunderKittens, great. We just got to invest across the board because we're selling shovels in the gold rush, right? So so you can't be like, oh yeah, I'll only sell you this if you go to this mine. I'm like, no, it's just pick a shovel and go wherever you want. So we will support every combination, but from a technology perspective, I think it's just speed of execution versus absolute performance.
Yeah.
And if you use the data for that, you will be able to choose what to do, right? It's like, do you want the latest model when GPT OSS 135B comes out, I don't know, whenever, or some combination, or Qwen 480B comes out? How long do you have to take it to production? And if you can take it to production in a few days and you're at 95th percentile plus in terms of performance, would you choose that? Or would you wait a couple months and get the extra 3%? Or there's a combination too. You deploy with Python first, and then you're like, okay, now I'm deployed and I'm going to go squeeze the next 3%. But by then the model changes and you're like, oh, great. So now what do? I got to go back and implement a new algorithm for this, right? So, you just got to be prepared for that change.
So you mentioned Qwen. Like, are we seeing where are you seeing from obviously you've got an international role. Where are you seeing interesting programming model, kernel innovation, like geographically speaking? Where are you seeing? We get so used to. Modular is obviously a Silicon Valley phenomenon, or at least a West Coast phenomenon. Like, where are you seeing interesting pockets of innovation that maybe people aren't expecting?
I think China definitely has a big flywheel that's just good, very talent dense, and surprisingly, they like a big open source push, right? Which is good for everyone. I think it's great. I've seen there are some companies in Korea that have taken on one or two spots. There is some traction or spinning up of the interest in India, but not as much as what I would say where China is. And China definitely is it's got like a first principles approach that it's starting to go down the stack, right? It's like how DeepSeek did DeepEP, and how it was able to hide communication latencies with compute and get creative rather than just using the stack that was available to them, right? So those kind of innovations push the boundary in terms of how we also perceive and how we can interact with the overall ecosystem. So yeah, I think Europe has a big presence too. We have some of our folks in the Silo AI team in Finland, and obviously London and UK. There's a big presence of models, and France too. Pretty big presence, and all of those places we try and help them achieve their goals with AMD hardware.
Okay. But I guess so. I'm interested. How do you talk about meeting developers where they are? Like, how do you do that? I mean, what does your team look like? There's only one Anush Elangovan. You can't be everywhere. So yeah, what does it look like from and engaging with the academic communities, with startup communities? How do you invest and meet people where they are so that you can find these innovations and make sure you're supporting them? The example you gave, who is it that you might give some hardware? I mean, if AMD wasn't talking to people at Stanford, that would be absurd. But I mean, maybe there's someone at Carnegie Mellon that you should be talking to, or, you're mentioning, other geographies, maybe, Imperial College in London, or, maybe it's in Paris. So, how do you, obviously a huge amount of AI innovation is happening in California right now, no doubt. But yeah, more broadly, and of course you also have to support sort of enterprise patterns, not just web company patterns. So how do you meet developers where they are, not so much in their IDE, but more broadly in the communities that they are, so that you can meet their needs?
Yeah, it's a very good question. So the way I think of it is one, I generally I have the philosophy that life should move on, or people should do the work even if you're there or not there. So I try to not be in the critical path and try to be clonable, so that it's scalable, right? Like you want the infrastructure behind you to be sustainable, so it's not node locked to one person.
By the way, everyone, if you want to schedule some time with Anush, good luck with that. So yeah, I'm not so sure about that lock, my friend. But anyway, sorry, go ahead.
Well, my calendar is a little messed up because a typical day in the morning has 4 to 6 conflicts, 2 or 3 of which I have to attend. So it's it is. So I try to time multiplex it and see how I can be there in multiple places. But coming back to your point on developers, right? I think our goal is to get to 10x of developer outreach for ROCm, 10 times what we have today, right?
What do you have today? What's your baseline?
It's up and coming. The baseline is it's getting good, but whatever it is, it has to be 10 times more. So good thing we're not starting from zero. We have hundreds of thousands of deployments, and it's good. But but there is a long way to go. So that ties into your earlier question on how we want to bring and reach the developer beyond just code IDEs, etc. Right? So we want to definitely leverage ROCm everywhere that a customer has access to an AMD GPU, right? For example, a Strix machine or your Epic CPUs, you just like the pervasiveness of AMD hardware is undersold. And what we want to do is first enable the software ecosystem on all of AMD's hardware ecosystem that's already pretty well deployed, and give a very smooth, common user interface between using PyTorch on your Windows laptop to running it on an Instinct MI355, right? Yes, the hardware is different, the power is different, but your basic Triton kernel that you write should be able to like generally run, in either spot, right? So this goes back to the other discussion we had on local LLMs and enabling local development. So that's one aspect where you have your personal AI box or machine or laptop where you can do 80% of everything you want to do. The only thing you can't do is scale. And then you just say, okay, deploy in the AMD developer cloud, and that gives you scale, right? So if we give that experience very like cohesively, then it starts to, kind of create a flywheel in terms of how we can kind of like ramp these things up. So I think the main thing that I would like to focus on in terms of metrics is, can we have sticky developers that wake up and they're like, I have to do this. And the first thing they do is like, let's get my ROCm platform running on AMD, and I have to be able to do whatever it is that they're thinking about, right? Like they shouldn't be thinking about anything else. It's just like, it should be magic down below, but we should enable them to be thinking about the last mile of AI, which is like, how do I take this to the end customer? How do I unlock value? And I often refer to this as like, AI is like the new electricity. And we still haven't, like, we literally are in the early phases of like, we found electricity. What do we do now, right? Like we can turn on a light bulb is what we've done so far.
We're still making the frog's leg twitch.
Exactly. Yeah. And so, but what we want people to be thinking about is not that, this is AC, this is DC, it's transmitting over a thing. What is it? It's like, we want them to be thinking about like, this is how you build a motor, and this is how you put the motor into an axle and put it into a wheel, and then put 4 of them and you get a car, and then you put it into a locomotive and you get a electric train. Like there's first order, second order, third order innovations that are still haven't even been imagined in my opinion, that we want people to be focused on, not the fact that, hey, I'm using AI. It's like, sure, that's fine, but we want them to look outward. And when they look outward and towards the unknown in terms of like what they can get and innovate on, we just become the back end. Like I mentioned, it's building and making the shovels so that everyone can
make those shovels. So it's always a pleasure to talk to you, Anush. We're definitely going to get in that 2-hour podcast at some point when we can get it scheduled, because I always find it fascinating talking to you. But today, I think we're going to cap a really interesting conversation about the future of programming on the GPU, where we are as an industry, where we find innovation. So yeah, thanks to you, Anush, for joining us. Thanks to all of you for joining us. Don't forget to like, subscribe, share this if you found it an interesting conversation, comment. And so yeah, once again, Anush, great talking to you, and great show. Thanks a lot.
This video was sponsored by AMD.